This video will describe and demonstrate the primary steps involved in replacing the head gasket on a naturally aspirated 1988 Porsche 944. I'll encourage anyone considering this job to consult the factory workshop manuals or at the very least Clark's Garage Shop manual and other sources of information before you begin. But hopefully this will give you a decent idea of the amount and type of work involved, as well as relay some tips and considerations. Before we begin, there is quite a bit of content here, so if you're looking to advance to a particular section or procedure, check out the chapters along the progress bar or the timing links in the description. So why am I replacing the head gasket on this car? I recently noticed a drop in power when driving the car, and I started to get some sweet smelling white smoke at cold start and a slightly discernible amount of coolant consumption. So I decided to run some compression tests, and on cylinder 1 returned 146 psi, 144 for cylinder 2, 145 for cylinder 3, and then cylinder 4, 30 psi. So the next thing I did is I checked all the fittings on the gauge to make sure it was connected correctly, and decided to run a wet compression test on cylinder number 4, and the result jumped about 7 psi. So enough information to know that it's probably not the piston rings, more than likely a valve issue of some kind, which isn't uncommon with these cars to have broken valve springs or slightly bent or damaged valves. So in addition to possible head gasket, we'll consider a valve issue. If this were a turbo that had a history of overheating, I might add in, warped or cracked cylinder head, but not as likely with a naturally aspirated. And so with the unknown gasket history and the mileage on the car and the testing that's been done, it's enough information to know that the head has to come off, and we'll do some repair and refurbishment on it. So another question is, how long does it take to replace a head gasket on a 944? To be realistic, replacing a head gasket is one of the larger jobs you can perform on the 944. On the low end, we could estimate about 2 hours to tear it down, an hour or more of cleaning, and perhaps 2 to 3 hours to reassemble. On the higher end, you're looking at 10 to 12 hours, and the car to be down for a period of days for machine shop services on the head, etc. So ideally the car would be garaged during that time. Removing the cylinder head from the engine block is actually quite simple, as it's only secured by 10 nuts. What complicates the process is removing all the components attached to the head. We need to be familiar with air filter housing and airflow meter removal and installation, fuel injector and fuel rail removal and installation, distributor cap and rotor replacement, intake manifold removal and installation, camshaft housing removal and installation, exhaust manifold removal and installation, coolant system draining and refilling, and the cylinder head tightening sequence and torque specifications for the rebuild. In addition to basic metric tools, sockets, ratchets, some hex heads, we will need a torque wrench for reassembly and some form of timing belt tensioning tool. This is the Maxi kit from Arnworks, which includes the flywheel lock, the pin wrench, and the spanner wrench. Something to lift the car, jack stands or ramps. We will be underneath to drain the coolant, remove the starter, and some of the lower accessory belts, but the rest of it will be performed from above the car. Here's a quick look at some of the parts that will be going on the car. The essentials include 2 gallons of coolant and a head gasket kit. This one's by Victor Rines. They make good quality seals, and it includes everything you need, as well as the valve stem seals, which is nice. The spark plugs on the car are a little bit oil fouled, so we're going to do the valve guides as well, make sure they're within spec, and replace the springs with the 944 turbo part. These springs are actually cheaper than the naturally aspirated ones, and they have a few extra pounds on the spring rate, so they reduce valve float at high RPM, which is nice. New hardware for the exhaust manifold, washers and nuts for the head, washers and plugs for camshaft housing, and things that we don't need but are going to be freshened up while we're in there include a replacement exhaust manifold. This is from an earlier car. one on the car now is starting to crack, so we'll get that taken care of. Cam gear cover, heater pipe, and heater control valve, as that one's starting to age and yellow a bit. And I've also got a water pump block-off plate because when I replaced the pump, it came with just the turbo version, so I have the original block-off plate on there now, so we'll get that replaced as well. Well, I've got the car up now, so it's time to get to work, and I'm going to start by disconnecting the positive terminal on the battery. There are some electrical leads here that go directly to the starter, and we don't want to ground out any tools when we go to remove the starter. Here's the location of the starter attached to the lower bell housing. We've got two 19mm bolts, one on either side, that mount it, an 8mm nut for this electrical lead, and a 13mm for this one. Go ahead and remove those first. I've got the electrical leads out of the way, so let's pop these bolts. And here's where the flywheel lock will attach once we set to top dead center. The next thing I'm going to do is remove the air filter housing and airflow meter. There are some 10mm nuts in front and some bolts in back, some hose clamps, and you may have one here as well for this radiator hose that I don't currently have installed. And then I'm going to remove the radiator fan assembly as well. 3 screws along the top and 3 along the bottom, 2 electrical connectors for the fan, and that will give us some more space to get at the belts. As parts are being removed from the car, I'll be tagging and bagging all the hardware, and that way it'll be much easier to reassemble on the other side. At this point, I'm going to go ahead and drain the coolant system. It's probably one of my least favorite things to do on the car. It's just really messy and gets everywhere, but let's get it out of the way. And the drain plug is on the lower driver's side of the radiator, comes out with a Phillips head. And I'm going to do my best to catch some of that as it comes out. I'm going to let this drain a bit more. Probably noticed the big flood that took place when I popped the cap on the reservoir tank. And then I'll put the drain plug back in. If you notice on these plugs, the O-ring is actually on the shaft of the screw, so it really doesn't need to be over tightened, and if you do, you'll end up popping the cap off these and need to replace it. Depending on how bad your head gasket failure is, you may have some mixing of oil and coolant. In that case, you'll need to do a coolant flush as well. But this is looking pretty clean, so I think I'll just be okay to refill. The next step in the coolant drain process involves removing the drainage bolt from the lower engine block on the passenger side. It is hidden down behind the exhaust manifold. And it's a 13 millimeter. If you have a smaller ratchet, you may be able to get it from above. Otherwise, might have to snake it down from underneath in between the manifold. And once that thing is out, the coolant will just run down the block and onto the exhaust and kind of all over down there, so get ready to catch it. Well, that was fun. I was about to thread this drain bolt back into the block when I had a look at the crush washer, which is mangled beyond recognition. So we'll add one of these to the incidental parts order. This is a 8x14 aluminum washer, and when it's tightened down, it's torqued to 14 foot-pounds. I'm going to go ahead and remove the fuel rail now, starting with this plastic cover. And the late cars typically have the fuel lines coming over the exhaust manifold. The earlier cars had them running this way. This is a Renbei fuel line kit, which I had Travis cut a little bit longer for me so I could route it back behind here for a kind of a cleaner look. It's possible to remove this rail and the injectors together, and you can set it aside. In my case, I'll be stripping it down because I'm going to have the fuel rail zinc plated along with some other parts on the car. The fuel rail is secured by 4 10mm bolts, 2 on one side, 2 on the other. You've got 4 electrical connectors, 1 for each injector. High pressure fuel line from the rail to the damper. The regulator is held in by 2 10mm bolts as well. A couple of vacuum lines, and we'll get it all stripped down. With the fuel rail out of the way, the intake manifold can now be removed. It's attached to the head with 8 6mm hex heads. Pull the J-boot back, 2 vacuum connections on the throttle body, disconnect the throttle cable. There are 2 10mm bolts, 1 on the oil dipstick tube and sensor connector bracket. A couple of vacuum connections, 1 above, 1 below, that can't be removed until it's unbolted, and 1 13mm bolt down below. remains now are the front and rear coolant flanges and the camshaft housing. To remove the camshaft housing, we will remove the distributor cap and rotor, cam gear cover, the belt covers upper and lower, and the accessory belts, power steering, and AC and alternator belt. Here's a look at another distributor cap, and it's held in by these hook screws that we push in with a screwdriver and then turn 180 degrees to disconnect from the cam gear cover, and the rotor is held in by a set screw. Below the car, you'll find the V-belt for the power steering pump and the ribbed belt for the AC compressor and alternator. There are two tensioning rods that need to be released. The power steering pump has two 13mm and the AC compressor has two 17mm. You'll need to release the pivot bolts on the mounts, one in the front, one in the rear. These are 13mm. And then on the AC compressor, there is a 17mm up front and a 13mm in the rear. Release those first, and then detension the adjustment arms, and the belts can come off. With the accessory belts off, the upper and lower front covers for the timing and balance shaft belts can be removed. There are 11 10mm bolts that work around, and then 3 bolts for the cam gear cover. I'm now going to set the engine to top dead center and install the flywheel lock so that the balance shaft and camshaft belts can be removed. Top dead center is when the piston in cylinder number 1 is at the highest point of its compression stroke. It's used to align all the components needed for proper ignition timing. Really, this process can be completed at any point after removing the starter, but for demonstration purposes, it's nice to see how everything moves together. Setting top dead center involves rotating the crankshaft in a clockwise direction while observing certain alignment marks. The transmission will need to be in neutral, and the engine will rotate more easily with the spark plugs removed or loosened. We'll use a 24mm deep socket or extension and a long ratchet to rotate the engine from the front using the crankshaft bolt inside the power steering pump drive pulley. There are a few different ways to determine top dead center. The first is using an alignment notch at the bottom center of the bell housing. The second is through a square opening in the top of the bell housing above the speed and reference sensors. It's important to note that the crankshaft rotates twice for every single rotation of the camshaft. So if we simply set the crankshaft to top dead center without looking at the position of the camshaft, we may actually be at top dead center for the exhaust stroke for cylinder number 1. We'll use the camshaft gear as a guide, and as the alignment marks get closer, we're looking for the letters OT to appear on the flywheel through the window opening on the bell housing. Stopping when the alignment marks on the flywheel match the alignment tab. At that point, all marks can be double checked and the flywheel lock installed in the location of the starter mount. Well, I was in a good mood, so I decided to attempt to remove this ignition rotor adapter or connector. These are known to provide some difficulty in getting off. The retaining bolt is said to be a 10 millimeter in a lot of the technical articles online. The parts catalog has it as an M5 by 10, which is technically an 8 millimeter. 8 millimeter wrench was kind of slipping on there and rounding it for some reason. I ended up using a 5/16 inch socket, which equates to 7.9 millimeters, and that was able to pull it off. It took a little bit of heat and a little bit of tapping. I ended up putting a drill bit in that hole and securing it with the set screw. And then I put a vice grip on the drill bit so I could wiggle it up and down, and I twisted it with a channel lock with some tape on it. I was able to get it out and got scratched up just a little bit, cleaned it up with some 600 grit sandpaper, and really all it needs to do is hold the rotor in place, so not a huge deal. And I think I'll go ahead and order a new bolt because they're only about $2. Just make sure everything's clean. It really was just caked with a lot of thread lock, I think was the issue, but it appears to be the correct bolt. Located in front of the timing belt is the balance shaft belt. There are two twin balance shafts, one upper and one lower, that rotate in opposite directions at twice the rate of the crankshaft. They work to offset the forces created by the pistons, which move at a 45-degree angle in what's a relatively large 2.5 liter four-cylinder engine. While the engine can technically run without the balance shaft belt installed, the shafts work to reduce vibration and improve longevity of the parts on the engine. Here's a closer look at the lower balance shaft. This system features a tensioning roller and an idler roller, both of which have a 24 millimeter tensioning nut and a 17 millimeter lock nut. So this has to be held in place while loosening the lock nut, and upon doing so, this can be rotated counterclockwise to relieve tension. The rollers and the gears can remain in place unless we are removing the water pump. In this case, we'll leave those on and simply pull the belt off and make note of the direction of rotation if you're going to be reusing the belt. With the balance shaft belt out of the way, we can now remove the timing belt. The earlier cars featured a tensioning roller similar to what we saw on the balance shaft system. However, in 1987, Porsche switched to a spring tensioning unit that has a 13 millimeter lock nut and a 13 millimeter bolt that will be loosened. Then insert the pin wrench into the faceplate, tilt it this direction to relieve tension, and then while holding it, we'll lock those connections back down so that it stays loose. Remove the 17 millimeter bolt on the roller. The tension will be measured on this upper span when we reinstall, and it helps to have a little bit of space there. And then two 10 millimeter nuts on the guide plate. And finally, the spring tensioner will be removed for clearance. It's secured by 3 nuts, 13 millimeter, one on the top right, one on the lower right, and one on the left just behind the hinged mechanism. I will say that while it is a whole heck of a lot easier to remove the timing belt with these pulleys and the crankshaft sprocket out of the way, in my opinion, it's more work to get those removed than just to tilt the belt sideways and work it out the bottom, which is what we'll do. And again, if you're reusing your belt, just make note of the rotational direction so that you can reinstall it the same way that it came off. Now that the balance shaft belt and timing belt are removed, we can begin removing the camshaft housing. In doing so, there are a few things to consider. Replacing the seals at the front of this assembly require that the camshaft gear be removed. However, this is an interference engine, so if this gear is turned in more than a couple degrees in either direction, we risk pushing the valves down into the cylinders and causing damage. To remove this gear, the retaining collar is a 1 1/4 inch fitting, and the bolt is a 10mm 12 point. This needs to be held steady while we release this particular bolt, which requires quite a bit of force. It's tensioned to 50 foot-pounds, and this has been in place for probably the better part of 3 decades, so I'm going to play it safe and just remove the entire housing first and then remove the gear after. To remove the housing, there are 6 8mm hex plugs that need to be removed, and underneath there are 6 bolts, which are 6mm, and there are 9 similar bolts at the bottom. You will need a long extension to get down in there for the ones that are inside the housing. Pull those out, remove the heater pipe, and there are 8 lifters in here, 1 for each valve, and so we'll attempt to tilt this down so that those don't fall out, and we'll put some catch rags down in here to catch any oil that may come out as well. Here's a closer look at the valve stems and springs. And I will mention that the rear support hanger that was on the camshaft housing, this little tab, was blocking access to the end bolt, so I did pull that off first. A lot of these will have up here mounted a connection point for the top dead center sensor, which I had removed previously on this car. And similarly in the front, power steering fluid reservoir was preventing access to this bolt. Just move that to the side temporarily. So we got to get off a couple of coolant connections, remove the heater pipe, and tackle the exhaust manifold, and then the head can come off. With the camshaft housing removed, I was able to perform an additional test using a shop vac by applying a vacuum through the spark plug holes for cylinders 1 and 4 for comparison. Cylinder 1 checked out pretty good, no strange noises, and I didn't feel any vacuum coming from the inlet for the intake. Cylinder 4, however, there was a slight whistling sound, and when I put a piece of rubber glove over the intake inlet, it was drawing the glove in through that valve hole. So the valve is not seating properly. From the surface, everything looks okay, but perhaps at some point in the car's history it was over-revved, or the timing might have jumped a tooth or two and bent the valve slightly. So more will be revealed when we get the head off, but looks like that valve at least will need to be replaced or inspected for damage, and that would really explain the low reading on the compression. So head gasket compromised possibly, but certainly the largest impactor probably that valve there. Here's the camshaft housing, removed, and the nice engineers at Porsche were kind enough to put the Zündfolge, or the ignition sequence, 1342, right on the top there. You can see all the lifters moving in sequence. So the first one is exhaust valve, and then intake, exhaust intake, etc. So if we get to 1, so 1 intakes, and then 3, while 3 is intaking, 4 is exhausting. And 4 comes up, finally 2. So we'll get these pulled out. If these are going to be out for more than a day or so, it's recommended to store them in some oil. So I'm going to keep them in sequential order so they go back where they're supposed to. And we can check the little buttons in here to make sure that they're firm enough. Fill that up with oil. Here's a look at the old seal versus the new one. Pretty crispy, and looked like it potentially had a failure starting there on the corner. Get those all pulled out, and then remove this cam gear, the front of the housing, and start replacing some seals. A gear puller tool would work well here. In this case, I just used a pry bar to work the gear off the front, and be careful not to damage the rear cover. The next step is to remove the camshaft key. These can be pulled out with a set of needle nose pliers or some diagonal cutters. Just kind of lift it up, and be careful not to squeeze too hard on it, damage the key. If you do, you can sand it down and reuse it. Got to remove these 3 bolts for the rear cover. And usually the front seal and the spacer sleeve will kind of slide out with it. loosened up. The seals we'll be replacing include the front camshaft seal, an O-ring on the rear cover, and a little gasket here, and a nearly invisible plastic mylar seal that goes in between the camshaft and the spacer sleeve inside the cover. The rear cover has a cork gasket, and I had previously replaced this. It looks like I over-torqued it. I didn't have the ability to use a wrench because I did it while it was on the car, and it's so tight back there. So I'd like to torque it properly with this off the car and then install it. But if I remember, this tab was blocking a bolt, so I may just cut this tab off because it's not being used, just so everything is to spec. And of course the housing gasket as well, and the 6 crush washers for the plugs, and it will be all sealed up. The camshaft itself just pulls out. You rotate it a little bit in some cases. And I'm going to have this housing cleaned. It's a little bit oxidized. So we'll keep that guy safe till we're ready to reinstall. There's no bearings or anything that need to be replaced in this. Looks pretty good. I was able to get the coolant flanges off without too much trouble, and then I went to do these 2 bolts. This long one here wasn't too bad, although it is a bit rough condition. However, this one did not want to come out, and it is bad state, and it almost stripped. And I had hammered it and hit it with some penetrating oil, and then I ended up heating the head and the block down there, and it just barely grabbed before stripping it. So we'll add these 2 to the parts list as well. And these particular bolts are known to strip or break, and strangely enough, they are not in the parts catalog. So if you're looking to replace them, a lot of times I'll use bellmetric.com. They have good rates, and they're M8 Allen bolts, 1.25 thread pitch. One is a 55 millimeter and the other is a 35 millimeter length. I'm going to begin removing the exhaust manifold by disconnecting the lower connections from beneath the car. And when you're working with exhaust system hardware, it's not uncommon for bolts to snap. The repetitive heat cycles of the exhaust cause the metal to stretch and expand over time, and they become brittle. And I had previously removed the lower portion on this car, and at least 2 of the bolts broke, if I recall. Typically, you can get a combination wrench on top of the bolt, and as you're turning from below, it'll rest up against one of the tubes and lock in place. And then if you have a variety of extensions and a universal joint, some of the connections are a little blocked off. But once you find the right angle, you should be able to get in there and get everything disconnected. hardware on the upper connections of the exhaust manifold are heavily oxidized in this case, and these are known to break as well. The factory stud system is installed and removed with a double nut or a jam nut procedure where you take two nuts and tighten them against each other. I've got an aftermarket kit going in by Renbei that has an Allen key on the end, which makes things a little bit easier to go in and out. So I'm going to try to wire brush some of the excess material off of these and hit it with some penetrating oil and let it sit for a while. See if that'll help. Probably the best case scenario is that these nuts are super fused to the studs and it just kind of comes out, the stud and the nut together, which would be really nice. Worst case scenario is that they all break, and then we'll remove some broken studs from the cylinder head. In removing these manifolds from the engine, there can be some clearance concerns that arise, much more the case when that camshaft housing is still in place. We shouldn't have any issues now that that's gone. So the 2 and 3 header will come off first, followed by the 1-4, get everything pulled out the top. Alternatively, if you'd prefer, you can remove the cylinder head with the manifold still connected on the upper connections and do that on a workshop bench if that's your preference. Here we'll just go ahead and get it pulled off while it's in the car. Alright, these studs have been soaking for a while, so time to see if we can break some of them free. And these will be 12 or a 13 depending on your car. Sometimes with stuck hardware helps to tighten it a little bit as well, help break the threads free. So that one's moving. Just gonna rock these back and forth a little bit. And some of these need to go old school on, where the tight bends on the inside. So you can't really get a socket on there straight. Looks like the nuts are moving. The studs are staying still. Alright, well, we've got both exhaust manifold pieces out now, and I only had to remove this one stud here to get it levered out and push down on the lower exhaust pipe a bit to make some space. We've got plenty of room here, so there may be situations that require the removal of more studs to get it out, and we'll demonstrate the double nut or jam nut process on one of these studs. So we're going to thread a nut back on. And the closer you get to the point where the stud enters the head, probably be safer if your hardware is really old. And then we'll put a second one on behind it. Until they're together. And tighten them down against each other. Pretty good. And now, because we're removing, we want the force to be on the inside nut. If we were installing, we would have it on the outside. And just gonna go slowly on this. It's starting to move. And again, you can kind of go back and forth with it a little bit on the threads so it doesn't break until it starts moving pretty good. And once it gets moving, just come right out. And there it is. So 5 more, get those cleared out, and then pop the head off. And the exhaust is now studless. No real issues there. Here's the crack on this number 1 pipe. Right along there. When Porsche first switched to the stainless steel tube design, there wasn't as much extra support built up on this Y pipe, and they would crack down lower. This is an 88, so they added more support, but they still just don't hold up over time. And that's why we got a new one. Removal of the cylinder head will require use of a 19mm socket and a breaker bar. The nuts are torqued in the neighborhood of 60 to 70 foot-pounds, so it can take a little bit to break them free. The loosening sequence will go from the outside in, crisscrossing, as to prevent any warping or damage to the head. So start number 1 here, 2, 3, 4, 5, 6, 7, 8, 9, and 10. There are a couple of pry points, lever points at each corner in between the head and the block, and it is aluminum, so it's relatively light. Just come straight off the studs, and we'll check it out. Well, here's the old gasket and the pistons exposed. They're about as roasted as I would expect them to be. The cylinder walls look pretty good. I see a couple spots of like light scoring, but it's not catching when I rub it. So I'm going to put some rags in these temporarily. You want to avoid getting all kind of dirt and debris down in by the piston rings, because if you don't clean it out well enough, it can scratch up the bores there. And of course we'll clean this much more thoroughly after, but let's see if we can get this gasket off. Had started it down here. Gasket rings are still intact, so no major blowout. This one is a bit crushed and warped. So that may have been part of the leak right there. And the big reveal is not a whole lot. So I was expecting to see a bit more evidence on this valve intake for cylinder number 4, it being cracked or slightly bent. There's no evidence of it contacting the piston, either on this valve or the piston itself, which I guess is a good sign. But it's still not seating fully or properly to get enough compression. It could be worn springs, but typically those are more noticeable at higher RPMs, and this is just kind of sitting here. And when I look at the springs, I'm not seeing anything cracked, but I can't see every single coil on the inner spring. So I was about to order an intake valve, and I think I'll just hold off. I'll let the machine shop tear it down, and they can cut the valve seats and relap the valves and measure everything and tell me if we need anything. And if so, we'll go from there. It's time to clean the engine block in preparation for the new head gasket and the refreshed cylinder head. All of these mating surfaces need to be smooth and dry, create a good seal on the rebuild. Generally, we're going to be using some Scotch-Brite pads for scrubbing, spray it down with either a little WD-40. Some people prefer to use non-chlorinated brake cleaner. You don't want to get too abrasive on this. The aluminum is quite soft. Some people use razor blades, but you just got to be really cautious to not take any chunks out of the metal. And you can also use like a rubber eraser wheel on a drill if you really need to get some extra oomph, but plastic scrapers are safe. So you definitely got to clean all around the mating surfaces for the gasket. You don't necessarily have to clean the surfaces of the pistons, but these carbon deposits do retain heat and can contribute to detonation. So if you want to do the best you can for your engine, it's a good idea to do that. Here's a piston from an earlier car. You can see they changed over the years, so the combustion area is a little bit larger, recessed on the early versus the late The 1988 had a higher compression piston, about 10 extra horsepower. But if we look, we can see where the rings sit. There's a gap there. And so material, when you're cleaning, can get all down around the top in these little grooves, and you want to make sure that that doesn't stay there when we go to start it, because it could potentially score the cylinder walls. So if you do decide to clean these, you're going to need to remove the flywheel lock and turn the crankshaft to move the pistons up and down, clean them when they're at the top position, and then lower them, shop backing in between, wiping them down, lowering them a bit more, just to make sure that all that stuff is out of there. The same goes for the water jackets. So the larger size of this engine allows for full water jacketing, which provides better cooling and performance, but it also means more cleaning. So we'll stuff a whole bunch of towels down there as best we can, and may need to flush it out with water if you can't get a vacuum in there, because anything that's left in there will just be swimming around in your coolant system. So let's get it done. Well, I have the carbon deposits removed from 2 of the pistons, and the gasket surface pretty close to where I need it to be. You'll know that you're in good shape when it has kind of a satiny gloss look to it, and if you see any spots that are flat colored or textured, like that part there, there's a little bit of gasket that needs to be scraped off. But do the best you can, make 2 and 3 passes to get it nice and clean. There may be some spots that are stained or discolored, and that's fine. It just needs to be nice and smooth. When the new gasket is mounted, it will compress and fill some of the minor voids, but you don't want any big chunks of gasket or anything left there. So we'll finish this up and see how it looks. Well, I've got everything all cleaned up, thoroughly vacuumed, and the engine returned to top dead center position with the flywheel lock installed. All that's left to do is get the head over to the machine shop for servicing and put together any final parts orders. Because this is going to sit out for a couple days at least, I'm going to go ahead and cover it up with a barrier against dust and moisture. You can use plastic wrap or some clean shop towels sprayed down with a light coat of WD-40. I've got the parts dropped off at the machine shop where they'll be rebuilding the cylinder head and cleaning the intake manifold and camshaft housing. Had a couple of parts orders come in recently. My brother made a donation to the cause by way of a gift certificate to an online vendor, and with that I was able to pick up a rear hatch seal. Not really related to this build, but I've been looking for one of those. Got a new air filter, some spark plugs, ignition rotor, and all the heater hoses behind the engine block. The ones on the car look okay. They're pretty soft and no cracks, but it's not going to really be a better time for me to get in there and replace those easily, so figured I'd do it. And shout out to Emmanuel at 944store.com for hooking me up with some new clamps for my J-boot, a bleeder screw for the coolant system, a gasket for the distributor, and some hardware for the hood latch, and he actually included a Hot Wheels 944 Turbo, so pretty cool, appreciate. I got one more order in for some crush washers. One's held up in Germany, so that may take about a week, and then just add up some odds and ends, and everything should be ready for when the head comes back from the machine shop. If you're performing this job and you've made it this far, go ahead and pat yourself on the back because you've completely leveled the top half of your engine, which is no small feat. And once all the parts come back, go ahead and get it reassembled. Installation is the reverse of removal, and good luck. Just kidding, it's not quite that simple. We'll be back for part 2 with some additional information and demonstrations on the rebuild and see if we can get this car back on the road.